Welcome back for another deep dive with us.
It's great to be here.
Today we're going all the way back to the 14th century
Ooh, okay.
to explore the work of William Heytesbury.
Interesting.
Now, he may not be a household name,
Hmm.
but he was really influential
Oh, okay.
in the development of logic and natural philosophy,
Yeah.
especially as part of the Oxford calculators.
That's right. A group of scholars based at Merton College, Oxford.
Who were really kind of pushing the boundaries of knowledge at the time.
Really fascinating group.
Yeah, and Heytesbury himself, he wrote a number of influential works.
He did.
And he had some pretty interesting titles,
Oh, yeah, like what?
like Sophismata Asina,
Which means
donkey sophism.
donkey sophisms. Okay.
And then there's Reguli Solvendi Sophismata.
What does that mean?
That means rules for solving sophisms.
So clearly he was interested in logic.
Yeah, like really into it.
And working through these complex puzzles.
Yeah, so tell me a little bit about what are sophisms?
Well, sophisms are basically arguments that seem plausible on the surface, but actually contain a flaw or a fallacy.
Okay, so they're like tricks almost.
Yeah, you could think of them as like brain teasers designed to challenge your reasoning abilities.
Okay, and
Okay.
Heytesbury was like
Yeah.
a master at...
He was a master at creating them,
Oh, really?
but also at dismantling them and explaining how they worked.
Oh, that's cool. So like he was playing these logic games with his students.
Kind of, yeah. He developed this really cool method called obligaciones.
Obligaciones.
Yeah, to analyze these sophisms.
Okay.
You can imagine it as a logic game with two players,
Okay.
the opponent and the respondent.
I like it.
The opponent presents a scenario, a casus.
Acasus.
Yeah, which could be anything from a simple statement to a really complex set of conditions, and then the respondent has to respond to each proposition trying to maintain logical consistency.
So it's like a back and forth. They're
Yeah.
going back and forth.
Yeah.
And trying to stay consistent.
Exactly, and they can agree, they can disagree, they can express doubt. Okay.
But the goal is to avoid contradicting themselves.
So they're trying to like trap each other.
Yeah, like a mental obstacle course.
Yeah, I like that.
Where each step you take, you could fall into a logical trap.
And I imagine some of these cases are pretty wild.
Yeah, some of the most interesting ones involve scenarios that were physically impossible but still imaginable.
Okay, give me an example.
Okay, so imagine a world where a vacuum exists.
Okay.
Something that was considered impossible at the time.
Right.
But Heytesbury said, okay, let's assume for a moment that a vacuum can exist.
It's almost like a thought experiment.
It is a thought experiment, using these impossible scenarios to test the limits of logic.
Okay.
And it's actually really similar to how physicists think today.
Oh, really?
Yeah, they use thought experiments all the time to
Oh.
explore the implications of different theories.
So even though Heytesbury's working in this medieval context,
Right.
he's using techniques that are still relevant today.
Absolutely. Yeah, that's really cool. Now, you mentioned that Heytesbury was also interested in how words connect to their meaning.
Right. He had this concept called suppositio.
Okay, suppositio.
It dealt with the different ways that words can refer to things in a sentence.
Can you give me an example?
Okay, so imagine you come across the sentence, man is a rational animal.
Man is a rational animal.
Yeah, Heytesbury would ask, okay, what kind of man are we talking about here?
Oh,
Are we talking about all men in general or a specific guy named man?
that's a good point.
So the way that the word man refers to something changes depending on the context.
Okay.
And that's what suppositio is all about.
So he's really looking at how the meaning of a word can shift
Right.
depending on how it's used in a sentence.
Exactly. And he was really, really thorough
Oh, wow.
in classifying all these different modes of supposition.
It sounds like he's like laying the groundwork for modern semantics and philosophy of language.
He absolutely was.
Yeah.
And this very careful analytical approach also shows up in his work on deductive validity.
Okay, so let's talk logic.
Let's talk logic.
So we all know, hopefully you know what deductive validity is.
Well, Heytesbury went beyond the traditional view of validity
Okay,
and actually identified 3 different levels of validity.
3 different levels.
Yeah.
Yeah.
So the first level he called formal validity.
Formal validity.
Yeah.
Okay.
And this basically means that an argument is valid if its conclusion follows logically from its premises.
Right, so the structure of the argument is sound,
Exact.
regardless of what it's actually about.
Regardless of the content.
Okay.
And then there's conceptual validity.
Conceptual validity.
Yeah. And this type of validity takes into account the specific concepts involved in the argument.
So the context matters.
Context matters.
No.
It's not just about the form, but about the meaning of the terms being used.
Okay, I'm following you.
And then finally, there's simple validity.
Simple validity.
Yeah.
Like,
And this is kind of the ultimate test. An argument is simply valid if it's true in all possible worlds.
Okay, so there's no way it could be false.
Right.
It's like the ultimate truth.
Exactly.
Yeah.
And so this three-tiered system of validity really shows just how deeply Heytesbury thought about the nature of truth and reasoning.
Yeah, so it sounds like he's really expanding on these traditional ideas of logic.
He is.
Yeah.
But he doesn't stop there. He also explores something called epistemic logic.
Okay, epistemic logic.
Yeah, so think of this as the logic of knowing.
No.
Instead of just analyzing arguments, we're looking at how we acquire knowledge and what it means to truly know something.
Okay, so it's like meta-logic.
It is metalogic. We're
No, no,
going
no.
deeper.
We're going deeper.
Right. And Heytesbury was very adamant that knowledge requires more than just strong belief.
Okay.
You can believe something wholeheartedly, but if it isn't actually true, it's not knowledge.
Right, so there has to be some basis in reality
Exactly.
for it to be true knowledge.
And he tackled some really tricky questions in epistemic logic.
Like what?
For example, he explored the idea of knowing that you don't know something, which is called negative introspection.
Okay, negative introspection, so being aware of the limits of your own knowledge.
Exactly.
Okay.
He also explored principles like the closure of meaning under entailment.
The closure of meaning under entailment.
Yeah, it's a mouthful, but basically it means that if you know a sentence, you also know everything that logically follows from that sentence.
Okay, so knowledge has this like ripple effect.
Yeah, it expands outward to encompass all the logical consequences of what we know.
Okay.
But he was also careful to point out that knowing a concept in general doesn't mean that you automatically know all of its specific details.
Right, so like I might know what a car is,
Right.
but I don't necessarily know how to fix a car.
Exactly.
Yeah.
There's a difference between theoretical knowledge and practical knowledge.
Okay, that makes sense. And all of this leads up to another area where Heytesbury was a real pioneer.
Oh, yeah.
Paradoxes.
Paradoxes.
Have you ever heard the classic, this statement is false paradox?
Of course, who hasn't?
Yeah, it's a good one.
It's a class.
Yeah, it makes your head spin.
Yeah, these self-referential paradoxes were something that Heytesbury was really fascinated by.
Okay.
And he came up with some really clever ways to analyze them.
Oh, cool.
He argued that these paradoxical sentences might actually say more than their words seem to indicate.
Okay, so like there's a hidden meaning that we need to uncover.
Exactly.
Yeah.
For example, he analyzed a famous paradox about Socrates saying something false.
Oh.
So imagine Socrates says Socrates is saying something false.
Okay.
If the sentence is true, then Socrates is indeed saying something false.
Okay.
But if the sentence is false, then Socrates isn't saying something false, which makes the sentence true.
Oh my gosh, that's so confusing.
It's a loop of contradiction.
Yeah.
So how do we make sense of this?
Well, how did Heytesbury make sense of this?
Well, he used his trusty obligationist game
Right.
to break down the paradox carefully, considering all the different possible interpretations.
So he's using this logic game
Yeah,
as a tool to really understand the paradox.
exactly. And what I find so admirable about Heytesbury is that he was very aware of the limitations of his own solutions.
Oh, really?
He knew that paradoxes are incredibly tricky, and he didn't claim to have all the answers.
Well, that makes him even smarter, right?
Exactly.
That he recognizes that these things are hard
Exactly.
and that there may not be one clear answer.
Yeah, paradoxes force us to confront the limits of language and reason.
Okay, so we've talked about logic. We've talked about these sort of like abstract logical concepts.
Right.
What about natural philosophy,
Ah, yeah.
which we would call physics today?
So remember how we talked about Heytesbury being a nominalist?
Right.
He believed that the world is made up of individual things rather than abstract universals.
So there's no like chairness.
There's no chairness.
There's just chair.
Chair are just chairs.
Okay.
And this nominalist view really shaped his approach to physics.
Okay.
He was interested in understanding how individual things change and move, and he used imaginary scenarios.
Imaginary scenarios.
Yeah.
In physics.
To explore the limits of these concepts.
It sounds like thought experiments again.
It is very similar to the thought experiments we discussed earlier.
Okay.
Heytesbury wasn't necessarily concerned with whether these scenarios were physically possible.
Okay.
He used them as tools to probe the boundaries of our understanding.
So give me an example. What kind of imaginary scenarios are we talking about here?
Okay, so imagine trying to pinpoint the exact instant when something starts or stops moving.
Whoa.
Yeah, that's what Heytesbury was exploring in his work on beginning and ceasing.
Okay.
He was trying to capture that fleeting moment of transition.
That's a really good one.
Yeah,
Yeah.
he was also fascinated by the concept of maxima and minima.
Okay, maxima and minima.
Yeah.
Tell me more.
This dealt with the upper and lower limits of things like strength or perception.
So like the most someone can lift
Exactly.
or the smallest thing you can see.
Yeah.
Okay. What are the absolute limits of possibility?
And to make things even more fascinating, he applied these concepts to something called the 3 categories of change.
Okay, 3 categories of change. I'm intrigued.
Yeah, so he categorized change into local motion alteration and augmentation.
Okay, so that covers pretty much everything, right?
Pretty much every way that something can change.
From moving through space to
Yeah,
like changing color or growing.
exactly.
This guy's amazing.
He's a fascinating thinker.
Yeah, so let's dive into these categories of change and see how Heytesbury applied his logical mind to understanding the physical world.
Let's do it. Okay, so let's start with local motion.
Okay, locomotion.
This is what we typically think of when we talk about movement. An object changing its position in space.
Right, like a ball flying through the air or a person walking down the street.
Exactly. But Heytesbury, being Heytesbury, he went a bit deeper and categorized different types of local motion.
Okay, like what?
Well, he distinguished between uniform motion, where an object moves at a constant speed,
Okay.
and difform motion, where the speed changes over time.
So a car cruising down the highway at a steady speed would be uniform motion. Right. And a car accelerating from a stoplight would be difform motion.
Exactly. And he even broke down difform motion into further subcategories.
Oh, wow.
There's uniformly difform motion, where the speed changes at a constant rate.
Like a car smoothly accelerating?
Precisely.
Okay.
And then there's difformly difform motion, where the rate of change in speed is itself changing.
So like a car that's kind of jerking and jolting as it speeds up?
He was very thorough.
This is pretty impressive.
And here's where it gets really interesting.
Okay.
Heytesbury actually formulated a mathematical theorem for calculating the distance traveled by an object undergoing uniformly difform motion.
Wait, a mathematical theorem? I thought we were talking about medieval philosophy.
That's the cool thing about Heytesbury. He really blended logic, philosophy, and mathematics together.
Okay, so what's this theorem all about?
It's called the middle degree theorem.
Middle degree theorem.
Yeah. And it basically states that the distance traveled by a uniformly accelerating object is equal to the distance it would travel if it moved at its average speed for the same amount of time.
Okay, I think I need an example for this one.
Sure. So imagine a ball rolling down a hill. It starts at rest and gradually picks up speed, right?
Right.
The middle degree theorem says we can find the total distance the ball traveled by simply averaging its initial speed, which is 0,
Okay.
and its final speed, and then multiplying that average speed by the time it took to roll down the hill.
So we're basically finding a midpoint between the starting and ending speeds
Exactly.
and using that to calculate the distance.
Precisely.
That's pretty cool.
And what's remarkable is that this theorem actually foreshadows Galileo's work on motion centuries later.
Oh, wow, really?
Galileo is often credited as the father of modern physics, but Heytesbury was already exploring these concepts way back in the 14th century.
That's amazing. It really
Yeah.
makes you wonder how much influence these early thinkers had on the development of science.
Absolutely. Now let's move on to the second category of change alteration.
Alteration. Okay, so we're not talking about movement through space anymore.
Right, alteration deals with changes in qualities, things like color temperature or the intensity of a sound.
So instead of an object changing its position, a quality is changing its intensity or degree.
Exactly.
So like a pot of water gradually heating up on a stove.
Perfect example.
Okay.
And Heytesbury, being Heytesbury, he had a very precise way of analyzing these changes.
Of course he did.
He explored different ways of measuring the speed of alteration, considering things like the degree of change, the size of the object, and the amount of change over a given time.
It sounds like he was trying to quantify something that's often perceived as subjective.
You're right, it's not always easy to measure how quickly a color changes or how fast a sound gets louder.
Yeah.
But Heytesbury was trying to bridge that gap between subjective experience and objective measurement. And ultimately, he favored measuring the speed of alteration by the amount of change over time, which aligns with how we think about rates of change in modern science.
So it's like he's laying the groundwork for concepts like velocity and acceleration, but applied to qualities instead of motion.
Precisely. And this emphasis on quantification and measurement also appears in his work on augmentation, the third category of change.
Okay, augmentation. So now we're talking about growth.
Exactly how things grow or expand.
Okay.
And Heytesbury's key insight here was to focus on the ratio of the new size to the old size as a way to measure the speed of growth.
So it's not just about how much bigger something gets,
Right.
but about the proportional change relative to its original size.
Exactly. So a tree that doubles in height is growing faster than a tree that only increases its height by 20%, even if the absolute increase in height is the same.
Okay, that makes sense. The ratio captures the relative speed of growth.
Precisely. And this concept can be applied to all sorts of things, from the physical growth of plants and animals to the expansion of knowledge over time.
It's amazing how Heytesbury is connecting these mathematical concepts to so many different phenomena.
And it's also important to remember that he wasn't working in isolation.
Right.
He was building upon the work of other Oxford calculators like Bradwardine and Kilvington,
Okay.
particularly their advances in the mathematics of ratios.
So he was part of a vibrant intellectual community.
Absolutely. They were all collaborating and building upon each other's ideas.
It just goes to show that the history of ideas is not a linear progression.
Right.
It's a messy, tangled web of influences and collaborations.
Exactly. And figures like Heytesbury remind us that even those who lived centuries ago can still have something valuable to teach us about the nature of logic, knowledge, and the world around us.
Yeah, I'm definitely feeling inspired to learn more about these medieval thinkers.
Me too! There's so much to discover.
You know, it's really amazing how these ideas from the 14th century are still so relevant today.
It's true. These fundamental questions about logic, knowledge change.
Yeah.
They really transcend time.
So as we wrap up our deep dive into the world of William Heytesbury, what's the big takeaway for our listeners?
Well, I think Heytesbury really challenges us to think critically and rigorously about our own assumptions.
Okay.
He reminds us that logic is not just an abstract system. It's a tool that we can use to analyze the world around us.
To really understand how things work.
Exactly. Even to explore the seemingly impossible.
It's like he's giving us permission to embrace the paradoxes and the uncertainty.
Right. To be okay with not having all the answers.
And to kind of revel in that mystery a little bit.
Yeah, to approach these complexities with a sense of curiosity and intellectual humility.
Because sometimes the journey is more important than the destination.
I think Heytesbury would agree. He was all about asking those tough questions, pushing the boundaries of what was known.
And you know what? I think he'd be thrilled to know that we're still talking about his ideas centuries later.
I think so too.
So to all our listeners out there, keep those philosophical gears turning.
Don't be afraid to ask those big questions.
Embrace the complexities and paradoxes.
And most importantly, keep exploring.
Until our next deep dive.